Earlier this week, we started with our new unit on slope. All we have done so far is identify what slope and the y-intercept is in an equation. Today, I'm going to challenge you guys to be able to use that information about slope to be able to look at graphs and place them with, you guys are going to be given these pictures of two rectangles. So the learning target for today is to apply your knowledge of the linear equations. That's just the regular equations that we've been working with to interpret graphs. So I want you guys to be able to tell me what's going on in these graphs. To be able to do that, we need a little bit of background knowledge. So first thing that I want you to do is take a look at this first container. This is two rectangles, one on top of another. On these two rectangles, they are exactly the same size. The total height of liquid in both is going to be 6 centimeters. 6 centimeters of water is the most you can have in the entire diagram. And that means in both the top and the bottom. So if I have 6 centimeters in the top, tell your partner how many centimeters of water you have in the bottom and how you know. Let me go, how many?
So the current population at Urban Promise Academy is 96% of our students are Latino. 100% of our students receive free and reduced lunch. We have a large population of students with some sort of learning disability.
Thank you. So what I heard my shoulder partner say is because we have to have a total of 6 all together, if I currently have 6 centimeters of water in the top, class, tell me all together, how many centimeters do I have in the bottom? 0. Because you have 6 total. That means top and bottom. Okay? This is often one where students get confused, so I wanted to spend a little bit of time on this. You have 6 centimeters total for both top and bottom. So I want you to look at the bottom here where it says, consider the following. If there are currently 4 centimeters, so I drew in some water for you guys, in the top, what is the height of the liquid in the bottom? So how many centimeters are left?
There's 2 left.
2 left. So we should say 2 centimeters. And if I only have 4 in the top, where are the other 2 going to go?
In the bottom.
Great. So can you please put that here? And then I want you to draw for me the 2. Then it's going to ask us at what height. So it's asking what the height is going to be. Will there be equal amounts of liquid in the top and the bottom? What does equal mean?
The same.
The same. So I'm asking you at what height? So we're looking for something in centimeters. At what height will there be equal amounts of liquid in the top and bottom?
At 4.
At 4, but if we had 4 here, what would be the same in the top?
4 here.
How much would that be in all?
8.
8. But can we have 8 centimeters?
No, we have to have 6.
6. In a minute, I'm going to ask you to check your work with the shoulder partner so you can explain it to me.
Yeah, because it asks at what height will it be equal. And since we have 6 centimeters, it should be 3 and 3.
So I really want the students to feel comfortable with having that dialogue and that conversation. So students always have an opportunity in a safe environment, which is one person first, before they have to share out what their thoughts are.
So let's review. It says, describe in detail the flow of water from the top of the rectangle to the bottom. When you look right now, I have not put any water in the rectangles. I want you guys to start to shade in what the water is going to look like. You're going to get that information, though, from this graph. This graph is going to tell you everything you need to be able to answer all of these questions. Some of them will be harder than others. So in a minute, you're gonna go back. You have to still write all of your own answers, but in shoulder partners, I want you guys working together.
Another big component of Common Core for me has been changing my lessons to give students more of these formative assessment tasks. So students are grappling with real-world applications, and it takes them a couple days. But I want to go deeper into those types of standards than just teaching the students steps of how to solve.
So if the height is 5 centimeters, what is our top rectangle gonna look like?
It's gonna be 8 from right here.
Why?
Because 5 centimeters between 4 and 6.
Okay. Leo, do you agree or disagree?
I agree.
Because?
Because like how she said, like the 4 is like between 4. I mean, because the 5 is between 4 and 5 and 6. So I think it's gonna go like the water's gonna go through here.
Great. And Cesar, how could you prove your answer by looking at the graph?
You can prove your answer by looking at the graph by
At what point do we start?
you start at 0.
0 what?
0 height or centimeter? Oh, time or seconds?
Okay, so has time passed at all yet?
No.
No, so where are we starting?
You're starting at 0 and then you're going to,
And so at the very beginning, how much liquid is in the top?
how much liquid? A 5?
5. So if you have 5 in the top, how many centimeters do you have in the bottom rectangle?
Oh, so you're gonna have 5.
So where's the 5? Is that going to be in the top or the bottom?
It's gonna be on the bottom?
Why would it be on the bottom?
No, I mean on the top.
Why?
Because what Leo said that it is between 6 and 4, so it's the 5.
Okay, so let's start off with that. I'm gonna come back to this table, and when I come back, I'm gonna ask you guys some questions about number 4. So I want you guys to work through 1 through 4 right now. Make sure that your shoulder partners can answer all of the questions.
Okay. So
For every second, the height is from the top, the water is flowing and dropping 1 centimeter for every second that's passing.
So Alfredo, can you tell me what you and your partner have decided, where does the water start?
It starts at 5 centimeters.
Okay, and how did you find out that information?
Well, we find out by the graph because every second that passes, we find out by the graph, and every second that passes, it drops 1 centimeter down.
I'm gonna be asking you guys about the liquid in the top and the bottom. While our projector's getting ready, why don't you talk to your shoulder partner to make sure that you guys can explain that well?
Since the introduction of the Common Core standards, my instruction in math has changed dramatically. I'm still teaching students the steps that are necessary to be able to solve problems, but it's my daily lesson that I've actually changed.
So how do you know how much liquid is in the top?
I know there's 5 centimeters in the top because that's how much it starts with on the graph. It starts at the 5.
Okay.
And since we have 6 centimeters of water in total, then there should be 1 centimeter of water in the bottom.
Great. You guys are going to have, thumbs up if you agree with Henry, sideways if you have a question for him. All right, good, sassy clap, go. The next thing that I'm gonna have you guys do, you have 3 minutes to get as far as you can with this classwork, and then we're gonna move on to the next activity. It's okay if you don't have them all done. The expectation is that the ones you do have done, both you and your shoulder partner can explain. Okay, so 3 minutes, go ahead and finish.
Because the water flows from top to bottom.
What is the starting liquid level?
5 centimeters, because that's how it starts is in the graph.
What does this mean about the bottom rectangle?
That it's going to be 1 because it has to equal 6. It has to equal 6.
So if you're telling me that after 5 seconds, how much water is left? 0. Let's try this. At 3 seconds, how much water is there?
2.
At 2 At 2 seconds, honey, how much water is in the top rectangle? 3. After 1 second, how much water was there? 4. So we're going to start here. What happens every second?
The water goes down.
The water goes down.
And so I'm going deeper in even the smallest part of my lesson. So throughout the entire day, students are being asked, what does your answer mean? Why does this make sense? Can you prove it to me?
You guys currently have these awesome graphs at your table. Couple things that I want you guys to know about these graphs. There are lots of graphs. Each picture of the rectangles has 2 graphs. One of the graphs is going to represent the flow of water from the top rectangle into the bottom rectangle. The other graph is going to represent the flow of water that is going into the bottom rectangle. This is our final project, so you will also be working on this tomorrow, but today you need to start. I'm going to come around and I'm going to be asking every person a question about your graph. It's okay for you guys to struggle through this. Remember, Triplet and I, we only got to 2 and it took us 13 minutes. Okay, you guys have 6. That's okay for you guys to take some time. So place all of your graphs out and all of your pictures so you can see what you have and start to match your graphs with your pictures.
This one.
Is there any other ones?
Yeah.
Only this one.
And the input 3.
Okay, so you have 2 graphs and 2 pictures. So this is a good start. You don't know for sure which one is which, but you'll start to figure it out more after you
I think this one's
identify.
this one because it's 1 by 1 second. These are going by 1.
So I want you guys to have that conversation because that's the conversation that I want to hear you guys have. So do that, and I'm going to come back and ask you guys some questions about that.
Yeah, I think
It's probably this one.
I think it's this one. Because it's going by 6 and it's going by, it says 1 centimeter per second. And this is going by 1s. And this one's going by 2s. And this is going by 3s.
Because like 4 centimeters per second. Because like it starts in 4 centimeters and in 1 second is already at 0. And then in 1 second is at 0.
Okay, so it's
So it's 2 centimeters per second.
I think it's 4 centimeters per second. Because it starts at 4, right? And then 1 second is at 0. So I'll say 4 centimeters per second.
So after today, this lesson is going to continue for at least 1 more day. Students are going to need to finish their final project of matching which pictures go with which 2 graphs. And they're going to need to justify that. Then we're going to continue on with learning more about slope, lines, linear equations, and we're going to do another task like this in another 2 weeks. If there's anything else that I could say about Common Core is that teachers really should embrace it. It's a really positive change that's supporting our students in moving forward, not only just with education, but for the rest of their future.